Okay, so I had very little idea of who would be here and how many would be here. So I'm going to pitch this from the following perspective. Yesterday morning, Louisa Koch noted that about 50% of the EPP graduates go into industry, about a quarter go to NOAA, and about a quarter go to academia. So my overview here, or my point is going to be, you can go to academia and still work with NOAA. In fact, it gives you more options. And I'll explain that as I go along here. I'm going to break this into 4 sections. They're not equally spaced. I'm going to go over CIs and NOAA initially. I'll talk about NGI specifically, then the relationship between CSCs and CIs, and then give you an idea of how a CI, a Cooperative Institute, works with NOAA. I'm the director of this consortium, or collaborative set of universities, and I'll get to that on about the 5th slide. So let me do something here. Okay. So first, I want to point out where and what the Cooperative Institutes are. They're very much like a CSC, okay, which I think most of you know a whole lot more about. You'll see on these, the locations, there's some double names. There's probably 2 reasons for that. Nominally, these are supposed to be rolled over every 10 years. Okay, you got a 5-year award, and then you can renew it for another 5. So the latest administration, to kind of show that these are not necessarily permanent Cooperative Institutes, have pushed to change the names and also to potentially change some of the players. As I go along, I'm going to, in 2 slides, show you a picture of where all the OAR, the research labs, are. I want you to notice how less diverse they are geographically. And in fact, NGI is 6 universities, and you can see it, the laser point doesn't work. So down here is the program office, but I'll go through the universities in a second. Just yesterday afternoon, some of you may have seen, NOAA announced a new CI, Research to Operations in Hydrology. It's going to be homed at the University of Alabama, 90 miles east of us at Mississippi State, but it has 14 consortium members and about that many related affiliates, so to speak. So this is not just a one university show in most cases. Now, some of them are. Cirrus is the largest. I actually have a table out front. They're associated with the University of Colorado at Boulder. CMUS is down in Miami, is predominantly University of Miami Erasmus. So there are some that are predominantly just one university horses. So what are they? I meant to say that. So their groups they're 1 or more universities that work with NOAA to help them do their mission. If you're not aware, it's a lot of effort to hire a federal employee, and very few federal employees are going to get fired. So once you make a commitment to an employee, there's kind of a 2-way stuck relationship. There's not a whole lot of ability to jump ship, and there's not a whole lot of ability to let you go. They may put you in a slot you may not want to do what they want you to do, but you got a job, okay? So NOAA's mission, as Dr. John Cortinas said yesterday, I could read it, but you can read it, and he said it yesterday. That's the mission, okay? He mentioned the line offices yesterday, but I want to go back through them kind of quickly. I think of these in kind of a diamond shape. The research office is on one point of a diamond. The 4 services are along the middle. And then the office, the sport office here for marine and aviation operations. And I don't want to put that left to right or top to bottom, but basically you've got the 4 services in the middle. So they support the research and the aviation office, marine and aviation operations support the 4 services. I'll skip the parenthesis stuff there. All right, so here's a map of all the research offices. So for those of you that are finishing a PhD, this is where the 7, I think it's only 7, OAR, Office of Ocean Atmospheric Research offices are. Now, Esrel is actually several labs. So there's like 3 or 4 out there. It's the biggest, and then the others exist. Now, once again, I pointed out earlier, the CIs are a lot more geographically diverse. So NGI, I'm going to use it as an example. I'm the director, but it's 6 universities. Mississippi State is the prime. Money flows through us and goes to everybody else. USM is kind of the co-prime. They're now affiliated with another, University of Southern Mississippi is affiliated with another CI. So they've kind of moved a lot of their efforts into that area. Dauphin Island Sea Lab is down south of Mobile, Alabama. It's actually now part of the University of South Alabama, I believe. Florida State, it's right up the street here. LSU, Louisiana State University in Baton Rouge, and then the University of Alabama in Huntsville. So all 6 of us work on different problems. We'll now go back and point something out here. So of these line offices, most of the CIs, 40% of the CI funding actually comes through the office of OIR, okay? But they did some measurements a couple of years ago, and it turns out that over half the funding to the CIs come from these 4 services. So the work that CIs do is not just write papers. It's not just pie in the sky work. It's actually working with these different line offices to actually do useful things, develop ocean models, understand how fish move, et cetera. So NGI, for example, our home lab is AOML down in Miami, where Dr. Cortinas is the director. There is a branch of NESDIS at Stennis Space Center. We have about 14 or 15 CI employees, actually closer to 20 now, that are working with them and supporting their work. With the National Weather Service, we're working very much. In fact, if I get to it at the end, the project I'll talk about is with the Lower Mississippi River Forecast Center. And we work with the weather forecast offices. National Marine Fisheries, the Southeast Fisheries Science Center is across the street from AML. They have labs in Pascagoula, Mississippi, Panama City, Florida, et cetera. We're working with them on several projects right now for the electrical engineers in the room. One of them is trying to use cameras and computers and machine learning to analyze catch and bycatch, rather than have to have somebody sit there, count the fish, and do those kind of things. National Ocean Service, we have a very large project with them on what's called regional geospatial modeling, trying to understand, to map coastlines, et cetera. I'll get into that a little bit more later. And then with OMAI, we have a lot of UAS work that they have to oversee, or they choose to. Okay, so NGI, all of the CIs have a list of research themes, somewhere between, I don't think any of them have only one, there's somewhere 4, some of them have 7. And so these are the areas in which NOAA offices have said, we need some help. We think we'll need some help. We want to fund them over the next 5 to 10 years. And so this NOAA came together, said, hey, we need a CI that will support this work. And these are the themes that we work under, okay? So NGI, the executive office is at Mississippi State, which is in Starkville, Mississippi, 4 hours north of the coast. Our program office, on the other hand, is down at Stennis Space Center. I'm going to talk about this a whole lot more. We share that building with a couple other institutes. That's fairly common, slightly off-campus research centers. And we're a large participant in the space and use of that building. All right, so down at Stennis, this is a 3-story building that was built back in 2012, and it's split in various ways. So you can see pictures of the lobby here, and I'll refer back to them in just a second. The first floor is administrative. So we've got MSU half and a NOAA half. That's where the directors, et cetera, sit. We have a classroom, we have a conference room, and then we have an exploratorium. So that room you can see in the through the glass there. In working with the Okeanos Explorer, what that allows NOAA to do is, rather than take a scientist, like a marine archaeologist, out to sea for 4 weeks, 2 weeks, whatever, when all they're going to do at one point is not be looking at corals or bathymetry, but a potential ship that sunk, and they want to understand, see if they can figure out which ship it was. Well, now that marine archaeologists can come up, say, from Tulane in New Orleans, they have full video with all of the ROV cameras that the Okeanos has, people on the ship, and they can tell them, move around, let's go here. And so a couple of years ago, an effort by an oil company doing seismic profile had seen a blip. They said, you know, that looks like that's a sunken ship. And so NOAA was interested in finding out what ship that was. They took the Okeanos out there, as I said, a couple of days of their 14 to 28-day mission. They actually were looking at the ship. So the marine archaeologists could tell them, move the camera here, go there, to look for various things that would help them understand which ship that might have been. All right, on the second floor of this building is now split. And it's kind of like peanut butter and jelly. One side of the building is all MSU. The other side is NOAA, but it has some MSU CI employees in it. So there's a lot of crosstalk there between the university's other research as well as what we're doing with NOAA. And then on the third floor, it's just kind of the same thing. It's MSU and, it's CI employees, mostly MSU. And almost all the services have a couple of people there. All right, so as I said, they're not all in one place. All right. Most of our employees happen to be, when I did this chart a year ago, we're down at Stennis Space Center. 4 of them are up at main campus. We have 5 down at AOML, and then we have 3 more scattered throughout the US. So CI employees are a lot of different places. In fact, we've got one that moved from here, was hired by NOAA. They couldn't put them at the lab because it was closed. So they said, hey, how about you host them at the university? We've got one that's moving right now from AOML back to Florida State. So that will happen soon. Orion is a high performance computer. This is the 5th largest computer in US academia. It's funded by a grant, 3 rewards over a period of time, 3 consecutive years from NOAA. And NOAA uses this, they allocate it. It sits at Mississippi State, but they decide who uses it for what projects. So a lot of high performance computing. All right, opportunities for you. So how can CIs and cooperative science centers work together, and what are challenges? Let me hit the challenge first. You're the challenge. We all want you. So the problem is when we try to work, the CIs try to work with the CSCs, there are people higher up in NOAA that say, well, how about the student go to the CSC university for 9 months and then come work on a CI project in the summer? Well, we want you 12 months. And I bet your professor at the CSC wants you for that summer work because you're not taking classes, you can work hard. And yesterday, if you didn't hear, there's something called NERTO, right? So NOAA wants you in the summer. In fact, they want you for 12 months. So everybody wants you. So that makes a challenge in trying to work together, okay? But I'm gonna show you in a second one solution. I already said it. We want you, okay? Y'all are really talented individuals. So let me give you an idea of the diversity, and I'm going to try to hit most of the universities in NGI all at once. So in geoscience at Mississippi State, I put just a few words over on the side about what some of these professors do. So if you're interested in that, they're looking for students. I highlighted 2 of them here in particular. This was supposed to happen 2 years ago. I was coming here to recruit. We've hired 2 more faculty members. Boniface is originally from Ghana. He is a world-renowned or up-and-coming climate model. Okay, PhD from Utah State, postdoc at Georgia Tech, another postdoc at Lamont Daugherty. So he just showed up in January, already going full steam. Okay, Jonah has actually got degrees from Florida State and University of Miami, doing air-sea interaction, so hurricane intensification, stuff like that. Rashid down here, since I'm running out of time, I'm going to be brief here. Is one of the success stories of how CIs and CSCs can work together. This is a proposal that Rashid put in, and it's collaborative with CCNU, City College of New York. Okay, in fact, this is the director, if y'all don't know, of one of the CSCs. So in doing this, there's collaboration, research at both places, at the CI, at the CSU. Environmental justice, I'm not even going to try it. The focus is on historically underserved and vulnerable communities, okay? Trying to get information out about disaster, tornado warnings, hurricane warnings, stuff like that, water quality. And this has just been funded this last year. All right, down on the coast, the ones I had on the first page are all up at Mississippi State, 4 hours from the coast. If you're interested in work along the Mississippi coast, there's faculty at MSU and at University of Southern Mississippi in various ways. I mean, Steve Howden is a physicist, okay, working in high frequency radar to understand waves and stuff like that. Down here at Florida State, FAMU, Mark and Sean, Dr. Barrasso and Dr. Smith, or Mr. Smith, have been longtime NGI funded participants in the research. So a lot of work there. Steve Dr. Moorhead was over at Florida State, got funded to work on climate effects on fish mortality, fish larval mortality. He's now moved over here to CCME. Dean Grubbs is down at the Coastal Lab working on sawfish, which is an endangered species. Some others, Luke is down at OML working on omics. So if you're a genomics type of guy, phenomics, up and coming scientists there, very well respected by NOAA. Brian and Ruth are both at the Dauphin Island Sea Lab, which is just south of Mobile. Brian, I'm running out of time, so I won't go into it too much, but Brian had some work last year where he studied the effect of a hurricane having come over an ocean area, and when the next hurricane comes, how does that potentially change its intensification and path? It changes the way the model works. Laura, well, she's into research to operation issues. So you do the research, but how do you communicate that, both to those that are going to do the forecast as well as to the community at large, society. All right, other joint work. I mentioned that early on. This is 3 of the 4 publications in AOML's publication list last week. We sent out weekly notices of who's published papers. 3 of the 4 papers, the lead author is in maroon here, is from NGI. The blue ones are actually AOML and NOAA employees at AOML. Okay, so you can see there's a lot of joint work here, even in the publication area. All right, how much time do I have left?
I think 5 minutes.
Good.
For questions here.
All right, so I'm good. All right, so this is one project of about, I don't know, 25. I happen to be the PI on this. I did this because I know the most about it and some of the others. And it involves a lot of different NOAA offices and programs. So we've been working with what was the UAS program office at OAR since about 2012 to help them build up their utilization, understanding of how to use unmanned aerial systems, or now called uncrewed aerial systems. They finally got the name well put. So floods are actually the largest, cause the most deaths in 1 year. Statistics show floods are what kill the most people, okay? So that's what we're focusing on. So the initial work here involved using small UAS. And so in this area right here, we're able to zoom in, collect a lot of data, high resolution, and see where inundated areas are from the flood, debris in the floodplain, and inundation near structures. What structures? Well, where people live, where power stations are. You know, when the water gets in the power substation, you got a problem. You know, it doesn't work too well. So they like to know that. Well, the problem here was in using these hand launch, which many of us can go out and do, or our students can. We were only able to cover about 6 to 8 square miles a day. Okay? High resolution, but we had 3 issues. One is we couldn't, the resolution was unnecessarily high, which made it a data problem for NOAA. They needed more area covered at lower resolution, and we needed to get the data to them much quicker to make it most useful. We were able to give them high resolution data, allowed them to really update their models. But in trying to do forecast, there was a better way to do this. So we pulled back. We worked with our Raspet Flight Lab to get about 150, 180 pound UAS. This actually was a target drone from Huntsville. So what we had to do was work with Griffin to harden it up, to get landing gear put on it, and then we put payloads in it. So that thing will fly, will cover about 50 square miles an hour, fly about 2.5 hours, and we get 6-inch spatial resolution with the sensor, which is more than enough resolution, spatial resolution for them. So two issues we were working on: give them immediate data on what the flood is early in the morning so they can make their forecast, and then give them high resolution data after the fact to help them improve their model and do post-event analysis. All right, so that was January. Our first trip, let me go back. First time we flew this thing and see if it would work. And the idea was to transmit the data from the bird to the ground station to the High Performance Computing Center, Mississippi State, which was the place all the data could be pulled from by FEMA, by NOAA, et cetera. We made sure it at least got to Mississippi State that day. We went back the next month in February to actually make sure we could do the full path down to the Lower Mississippi River Forecast Center, which is near New Orleans. And lo and behold, we hit the 5th highest flood in the area ever. So it was an event that they really wanted to understand and capture. So in the middle here is a Google Earth image, and I've circled a couple of things. They base their flood, here's what's happening, on one value from one gauge, that Whaley gauge. It's about 20 miles north of Greenwood, Mississippi, which is not that big a town, maybe 50,000 people. But it's a farming area, et cetera. On the hydrograph page to tell the community what the flood is going to be like at certain levels, in this case, 26.5 feet. The only description they have for that whole area of about 20-mile diameter is water is entering the yard surrounding the old Whaley Gin building, okay, out in the middle of nowhere. And that's supposed to tell the whole area just how high the water is, okay? So what we're doing here is providing them images so they can put it on the web page. And so when the gauge says 26.5 feet, they can see what the impact is. You can see there in the pictures on the left and the right. All right, their model had an issue. It turned out there's actually a poster downstairs by a young student by the name of Cassandra from UTEP about mixed pixels. They were having a mixed pixel problem. Their models were based on images from satellite, which were much lower resolution, okay? And so what they were seeing were treetops and seeing no water storage. So the models had the flood not happening as fast and persisting longer because they weren't seeing in their models the storage underneath the trees. So this is the base image. There's the gray and black over there is the path of the UAV. When it flew back along here, this all of a sudden said, whoa, wait a minute. There's water being stored under these trees. Though there's levees there that make it look like the water isn't going to get out. I mean, you can see this is the river here and there's trees and levee all along there. It was. Somewhere it was seeping out and getting over in these areas. In fact, I was really impressed. The hydrologist in charge, who's head at the RFC, we had a grad student down there to make sure everything worked. Remember, it's only the second time we were trying to do this, and we didn't want to impact the forecasters' work. We're trying to help them, not give them more work to do. He's pulling it up on a big screen, much this size. The hydrologist in charge, the hick, walked along and he goes, oh, shit. This showed him exactly what part of the problem was. So that's my favorite line from that whole incident. All right, so UAS, what are they, so forecast, what is it really helping you? All right, this is an extraction from all of the data we flew in a day and a half, okay? This is at the same time, but I'm zoomed in on that circle up there. So this is about noon on February 24th. This is about 11 a.m. the next day, okay? You may not be able to see it from the resolution, but notice this road is clear here, all right? Notice in the base image, they're in this house here, right? So somebody's come along in the last year or two, built a house. There's a car in the driveway here. They weren't stupid. There's no car in the driveway here the next morning. The road is flooded here, and I suspect it was really close to being flooded there, not flooded. So in 23 hours, we were able to show them the change in the flood level. Now, it only changed a foot or half a foot. In fact, I'm not even sure. Yeah, here it is. Well, that's not quite right. But anyway, it only went up less than a foot, but that caused the road to be cut off, okay? It also turned out that was the mayor's daughter-in-law. So when she saw this, she made a presentation, she goes, I'm gonna have to talk to her. So what a good place to be building a house. All right, while we were flying the larger UAS, we also took the hand ones out there, went to hot spots, and were able to provide them these oblique images so they can see more of where the flood is. So this was a bridge that we were rebuilding. This should have been just farmland, but it was flooded for miles and miles. As I said, that Griffin G2E was a prototype aircraft. With the Federal Aviation Administration, they're much more comfortable with aircraft that have had more use in improving the use of it. So we're working with our flight lab, we were able to acquire, they got about 4 of these now. A lot of specs. The biggest thing for us is we can go 8 hours. The problem with that is we have to use a chase plane, and the pilots in the chase plane have to come down to use the restroom, get more fuel, and get more food. So we put the UAV up, we go do mission, follow it around, have to come back, loiter above, pilot comes down, does his thing, takes the plane back up. So we can cover a lot more area, we go a lot farther away, etc. So that's what we're using now. And there's the acknowledgement, and with that, any questions?
Yep, and we have time for a few questions.
Yes, sir.
What hours are you going to be at your table?
I don't have a table. You'll just have to find me, but please do. I'll be here till late this afternoon. I'd love to talk to any of you. I'm going to assume all these people that are coming in late just slept in. It's not because they knew I was going to give a boring talk. So y'all come on. Yes, sir.
So you were mentioning a 6-inch spatial resolution.
Right. Right.
So does that mean that your camera was able to come down to you made at 6 inches?
So the image is, thousands of feet wide. each pixel is 6 inches wide. So we're getting 6 inches width of data. So we're able to resolve objects that are a foot wide.
Wow, that's
Yeah, 4,500 feet. Yeah. Good question.
Any other questions?
Any plan to add LiDAR system there to know the depth of the water?
Very, very, very good question. So we're flying LiDAR on our handheld right now. We are debating about, it's really a cost benefit analysis type of thing. We have with the Tiger Shark the ability to put LiDAR on there. We're just looking for somebody that finds it necessary to do it. The UAS, long time in the air, LiDAR often isn't a big advantage. With the floods, you've got a dynamic event. So being able to stay up and do a lot of work in a short period of time has its benefit rather than go up, come down, go up, go down. With the LiDAR, it's often static that you're looking at. LiDAR ain't going to help us with the depth of the water. It will help us with the topography ahead, right? I mean, it's going to go through the water in most cases. Does that make sense?
Could be, but if you're pre-mapping.
Right,
And then you second map, then you see the change detection, how much
Exactly.
depth of change.
So we would do the LiDAR in a dry riverbed or before we actually have the flood so that we have the digital elevation. Exactly. So right now, the manned aircraft are often still used for that and satellites. And I would say in some ways it's federally provided data or state provided data in a lot of cases.
All right, thank you so much. We have
Thank
to move on to our next